We also have Pythagorean identities that we talked about the other day. Our fundamental Pythagorean identity is the one we learned earlier in the semester, which says that sine squared plus cosine squared equals 1, no matter what angle we plug in. Sine squared of that angle plus cosine squared of that angle always equals 1. And as we did in class, we can take this identity, sine squared plus cosine squared equals 1, and divide each term by, let's say, cosine squared x. Alternatively, we could take our same identity and divide each term by sine squared x. Using our definitional and reciprocal identities from before, what did these simplify to? Well, the first one, sine squared over cosine squared, that's just going to be tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared will be secant squared, and that's our second Pythagorean identity. Tangent squared plus 1 equals secant squared. Similarly, if we take that last line that we wrote and simplify it, we get 1 plus cotangent squared equals cosecant squared x. Remember that first identity we did last video? It's simplified to 1 plus cotangent squared. And so if we wanted to, we could simplify that even further to cosecant squared, or equivalently to 1 over sine squared x. Let's practice. We want to fully simplify the expression 1 plus cotangent squared x, all divided by secant squared x minus 1. Now we'll recall that one of our identities tells us that 1 plus cotangent squared x equals cosecant squared x, and the other one tells us that tangent squared x plus 1 equals secant squared x. We're going to use both of these identities in simplifying this. We'll notice that the numerator of this equation is just the left-hand side of one of our identities. Therefore, we could simplify this by writing this as the right-hand side of that identity, cosecant squared x. Now, we don't have secant squared minus 1 anywhere, but we do have just a secant squared. And if we subtract 1 from both sides of this equation, we can see that secant squared minus 1 is equal to just tangent squared x. But we're not done. Now we can use our definitional and reciprocal identities to rewrite this as 1 over sine squared x divided by sine squared over cosine squared x, and then simplify this the same way we always simplify fractions of fractions. We can write it as 1 over sine squared x times cosine squared over sine squared x. And we'll notice that this simplifies down to cosine squared over sine to the 4. And I don't think we can really get any simpler than that. We could rewrite this a number of different ways, but this is broken down into just sines and cosines now. In class, we will practice simplifying expressions just like these. We'll also learn new identities for the sum and difference of angles, as well as double and half angle formulas and how they're related. And finally, we'll use these formulas to find new values of sine and cosine. See you then.